Alright, so we're finally on the last video here, and let's start with number 42. We've got a difference of squares here that we're asked to factor. These are actually pretty easy. We need two numbers that what number we ask ourselves. Well, first of all, we know that it's going to be two binomials. And actually, I'm just going to go ahead and write the answer here. We know it's going to be, I always say to myself, what times itself is x squared, what times itself is 36. And so that would be minus 6 and a plus 6. We're always going to get the same numbers with opposite signs. On number 43, you've got four terms. So we want to factor by grouping. And you can see the first two terms have a common factor of x squared. And then x squared times x would be the x cubed, and minus 3 would give you the minus 3x squared. Now, when we factor these two terms, we could factor out a negative 4, and it'd be negative 4 times x minus 3. I usually just rewrite whatever we got in the parentheses on the first two terms, because we know that's what we expect, is to get the same factor. And if we don't, something's wrong. And notice here I just need to multiply by negative 4 to get the minus 4x there, and negative 4 times negative 3 gives you 12. And so now we can write this as x minus 3, our common factor, times x squared minus 4, which is another perfect square. That'll be x minus 2 times x plus 2. And so we have three factors here. On number 44, we're going to use the AC method, or you may think of it as the split B method. And so we need, and that's because we have a trinomial. There's no greatest common factor here. So we need two numbers that multiply to 12 and add to negative 8. And you can look a little bit, but you'll find that it's negative 2 and negative 6. Notice negative 2 times negative 6 gives you the 12, and negative 2 plus negative 6 gives you negative 8. And so in this case, we do have a 1x squared, so we can just put those numbers in. But I'm going to go ahead and do this the long way. We're going to split our b term. And so the first two terms we can factor out an x times x minus 2. So here we're going to expect to get another x minus 2. And I need a minus 6x to start, so I'll put a negative 6 in there, or minus 6. And notice negative 6 times negative 2 does give you 12. And then we can write that as x minus 2 times x minus 6. And again, like I was saying earlier, you can see what's here. We could have just put right in with the x's there. And we can always do that when we have a 1 there. So notice on number 45, that's not the case. It's 6x squared. And so for on this one, we're going to have to do it the same way I just did the other one. So our AC here is going to be 48, and our B is 19. Notice I've put down all the factors of 48. And we need the two that add up to 19, so that would be the 3 and the 16. And so let's go ahead and split our b term. I'm going to erase this up here. Alright, so let's bring down the 6x squared and split 19x into 3x plus 16x, and then bring down the 8. And for our first two terms, 3x would be our GCF, times 2x plus 1. So here we're going to expect to get a 2x plus 1, and 2x times 8 would be 16x, and notice 8 times 1 does give you 8. And so here we get 2x plus 1 times 3x plus 8. I would just remind you that when we factor, we can always multiply to go in reverse and check our answers. You could do that with all of these. All right, on number 46, we've got a rational equation. So to clear fractions, we're going to want to find the LCD. Notice we have no restricted values because we don't have an x in the denominator of a fraction. And so, let's see, I always start with the largest denominator. In this case, it'd be 5, until I find I've got to find a multiple of 5 that's divisible by 2, 4, and 3, the other denominators. Of course, 5 is not divisible by 4 or 2. 10 is not divisible by 3. I only have to find one number that is not dividing into the number, and I know that it's not going to work. 15 is not going to work. In fact, it takes a while to find the one that works here. You've got to go all the way up to 60. Notice 60 is divisible by 2. You divide by 4, you get 15, so that works. It's certainly divisible by 3, and it is divisible by 5. 60 is our LCD. That's the hardest part of this problem, is just finding the LCD. We're going to multiply all of the terms by 60. And so 60 divided by 2 is 30. We're going to have 30 times x, or 30x. 60 divided by 4 is 15. 15 times 1 is 15. So we have a minus 15 there. Make sure you use a minus. On the other side, 60 divided 3 is 20. So we have 20 times x. And 60 divided 5 is 12. And so we've cleared the fractions. Now we need to get x on one side only. So we'll subtract 20x on both sides. You get 10x minus 15 is 12. We need to add 15 to both sides. We get 10x is 27. So we're going to end up getting a fraction for an answer here. So let's go ahead and I'm going to rewrite this up here so I have a little more room to work. Let's divide by 10 on each side to get x by itself. And so we do get 27 over 10. On number 47, we're solving an inequality, and we know we solve these just like we do equations. The only thing is, if we divide by a negative, we have to reverse the symbol. And when we get our answer, it's not going to be just one number. It's going to be a set of numbers. That's why we write it in our answer in interval notation. So I would start here by distributing. I want to get rid of the parentheses here. So 3 times x is 3x, and 3 times a minus 2 gives you a minus 6. On the other side, 5 times 3x is 15x, and 5 times a minus 18 gives you a minus 90. So you'll notice this is a lot like the problem we did up above. We need to get x on one side only. So we'll end up with a minus 12x minus 6 is less than or equal to negative 90. And it's going to take 2 more steps here. To get x by itself, we're going to need to add 6 to both sides. And then notice at this point, I'm going to go ahead and rewrite it up here. We need to divide each side by negative 12. And when we do that, we are dividing both sides by negative, so we're going to have to switch the symbol. We get x is greater or equal to 7. I'm going to go ahead and graph this first. We're going to start at 7. The numbers greater than 7 would be to the right of 7. And of course, we're going to put bracket at 7 because of the equal sign. And if we go from left to right, we start at 7. And forever right, that's what we call infinity. All right, so let's look at number 48 now. Now, there's a few basic rules of exponents that we should know, and 2 of them are going to apply here. The first one is when you have a power to a power, we use what's called the power rule, and we multiply the exponents. So an example, a cubed squared would equal a to the 6th. And then the other rule that we're going to need is the product rule that says if you multiply 2 powers of some base, the same base, that you just add the exponents. And so that's the product rule. So we're going to need both of those here. So first of all, we'll need the power rule. We're going to take everything in here in this first fraction to the 4th power. So we've got x to the 4th. We'll just write that. You could think of it as 1 times 4 if you want to use the power rule. Y squared to the 4th power, that's a power to a power, so we're multiplying 2 times 4 to get 8. Z cubed to the 4th will multiply to get 12. And of course, w to the 4th would just be w to the 4th. And we'll do the same thing with the other parentheses. We got x squared cubed, so that'll be x to the 6th. Y to the 3rd power. In the denominator, we have w squared cubed, so power to a power will multiply. We get w to the 6th power. So when we multiply fractions, we multiply straight across. So we're going to multiply our x's together. X to the 4th times x to the 6th will be x to the 10th. Y to the 8th times y cubed would be y to the 11th. Again, we're just using the product rule and adding the exponents here. Now be careful, z to the 12th, we just rewrite, there's no other z. And then in the denominator, w to the 4th times w to the 6th is going to give you w to the 10th. All right, let's look at number 49. So I call this problem FOIL in disguise. We can't just square the 2x and the 5y here separately. We don't have any kind of rule or exponent rule for that kind of thing because we have two terms here inside the parentheses. The only thing we could do is write two of these multiplied. That's what it means when you square a number. You're going to multiply two of those. So now we're just going to FOIL this. We get 2x times 2x is 4x squared. Our outer product will be a minus 10xy. Same thing for the inner product. Notice, again, it's always a good idea to put your variables in the same order so you can see that these are like terms. And we generally put them in alphabetical order, although I don't know that I always do it that way. As long as they look the same, that's what I care about the most. And then negative 5y times negative 5y will give me a positive 25y squared. And so we do have some like terms there. We'll add negative 10 and negative 10 to get negative 20xy. And that's going to be it for that one. Let's move on to number 50. So when we simplify radicals, they don't always have to be simplified, only if we have a perfect square, like square root of 25 we would write as 5, or if the number under the radical, what we call the radicand, has a perfect square factor other than 1. So these are my perfect square factors other than 1, and I just went up to 36. That should be plenty for what we're doing here. Notice 75 is divisible by 25, so we can break this down into two radicals multiplied. Square root of 25 times square root of 3, and the square root of 25 is 5. So the simplified form is 5 times the square root of 3, or 5 square roots of 3. On number 51, I know I'm going to have an imaginary answer because I'm taking the square root of a negative, so I can pull out a square root of negative 1. And as far as 45 is concerned, that is divisible by 9, which is a perfect square. And so it'll be 9 times 5. So the square root of 9 is 3, and of course the square root of negative 1 we call I. So that's 3i times the square root of 5. All right, on number 52, let's see, it says, well, we've got Mary building a garden. She wants to put up a fence so she can keep out pests. And in order to fit correctly, the length of the garden must be 1 foot less than twice the width. If she purchased 82 feet of fence, so we're going to be talking about the perimeter here. That's going to be for the perimeter of the garden. What must the length of the garden be so that she uses all the fencing? So we don't want to waste any fence. Well, let's draw a picture. And notice here it says the length of the garden must be 1 foot less than twice the width. So the length is, we need it to be 1 foot less than twice the width. So twice the width would be 2w. And if you want 1 less than that, you subtract off 1. It's just like if you wanted 1 less than 100, you would start with 100 and subtract off 1. All right, so we've got one of our equations. We're going to write a system of equations here. Although we've done it both ways, we could work in just one variable. But it's very natural to use two equations here. It says the perimeter is 82. We have a formula for perimeter. So here's our width, here's our length, and perimeter is 2 widths plus 2 lengths, or 2 times w plus 2l. But we know the perimeter is 82, so there's your other equation. So this one is pretty much set up for us to use the substitution method. We're going to go ahead and substitute for L in the second equation there. So we've got a 2w plus 2w minus 2 times 2w minus 1. Let's go ahead and distribute here. We get 4w minus 2. We can combine the w terms. We get 6w minus 2 is equal to 82. And we'll add 2 to both sides and divide by 6. And the answer there is 14. Now we were asked to find the length. Well, the length is just twice the width minus 1, so let's go ahead and plug in 14 for the width. That'll be 28 minus 1, which is 27. So 27 feet is our length, which is actually what we were asked to find. I usually just answer or give both, but the 27 is what they really wanted here. All right, number 53, we know that negative exponents lead to reciprocals. If 4 squared is 16, then 4 to the negative 2 power would be 1 over 16. The other way to do it is to use the definition, which is x to the negative n equals 1 over x to the positive n. So this is 1 over 4 squared, or 1/16. I don't care how you do it as long as you end up with 1/16 there. And it should be written as a fraction there. It does say no decimals. And then rewrite using rational exponents. We learned that there's a relationship between radicals and fractions as exponents. And the main thing is the denominator of the fraction is the root of the radical. So in this case, this is a 4th root, so it's going to be z to the 3/4. The 3 comes from the exponent on the z. On number 55, so we're going to be looking at a 5th root there. Now we're writing in radical notation. And notice I put the 6 on the x, or I could put the 6 outside. But the main thing is the root is always the denominator. That's going to be 5 here. All right, and we have completed the review.